Hi everyone, and welcome to Nginx Sprint. My name is Timo Stark, and I'm a product management engineer at Nginx. And I'm happy to be here with Elijah today.
Hi there. My name is Elijah Zubanchik. I'm a solutions architect on the Communities and Alliances team.
Yeah, and today we are talking a little bit about Nginx Unit, and would like to give you a short overview about Nginx Unit, what it is, and how can it be configured. So yeah, Nginx Unit is a polyglot application server, a reverse proxy web server, and a lot more than that. I would not stick to this app server term too much because it is definitely something that can run your application code, and there is a lot more than just application server capabilities that you need to run your application code on a production environment. And yeah, that's exactly why we're here today. Because we want to show you what Nginx Unit is and what capabilities we have in Nginx Unit. The Nginx Unit core, so to say, can be configured with a RESTful API. So it's no more configuration files in a common way you think of. It's an API interface where you can send your configuration changes to. And all those changes can be made without zero downtime. So you configure something and Nginx Unit will take care of reconfiguring your processes and your main process without even affecting the uptime of your application workloads. That's pretty cool. This polyglot application server, what does it mean for what does it stand for? And by today we support 8 different languages. So that means that you can use 8 different languages or your applications written in 8 different languages, and all those can be hosted on a single Nginx Unit instance. So, for example, you mentioned PHP and Ruby, and over that we support Python, Perl, Java, and JavaScript as well. So Node.js is a very common one, or Go applications are very widely used, and all those can be hosted on Nginx Unit beside each other. So you have one unit installation, and on this unit installation, you manage your PHP apps, your Ruby apps, your Node.js apps, Perl, Python, no matter what it is. It's a single unit instance, and it's one configuration API. And this powerful features is something I really like to demonstrate you here today, and how it can be used.
So, Timo, what I'm hearing, no pun intended, is that you can compose a single API made up of applications running in very, very different languages and platforms, and that all becomes one single deployment unit.
Right.
That you can deploy. So, for example, like I might be a Ruby shop, but we really need to use NTLK for natural language parsing, and we've got some legacy old Java backend. But really, what we're deploying is a single application from a end user standpoint. Those can be bundled together, and then we scale that all as a single deployment unit using Unit.
Right. That's correct. So if you want to say that your unit server or your unit installation is your deployable artifact, there you can have anything you've just mentioned in this unit and deploy it as a single package. So that means you can have your Java app running on the same server, on the same app server as your Ruby applications, or static files like images, JavaScript files, CSS, whatever it's needed to deliver your services and your applications to your customers. That's why I'm saying this application server, polyglot application server, is a good description for a specific part of Nginx Unit. But at the end, it's a lot more than just an application server, because there is a lot more needed to deliver your services, your applications to your customers than just the capabilities of an application server. And one is definitely the network part, so anything that's on layer 4, and the security side of things. And this is something that becomes more and more important. The more you go into the cloud, the more you go in environments that you do not really have in your basement as they were before. Then security and encryption is a very, very, very important part of the story. So Nginx unit do a lot for securing the application processes when it comes to isolation, and features to isolate the root FS, isolate the processes, and keep things in itself secure. So that means that your application processes are living next to each other on a single VM, on a single box, in a single container. But we do, or unit do, anything that's possible to isolate those processes if configured and needed. One feature, and another one is definitely the encryption of incoming traffic. So means you have a proxy server, you have an API gateway, which is really, really common setup. You have something that sits in front of your unit most of the time. And no matter if it's doing initial TLS termination or something, the buzzword zero trust environment is nowadays more present than ever. So you really do not want to have unencrypted traffic flowing through the network, even if it's inside of your VPC or of your network zone on a cloud provider. So you really want to encrypt the traffic that's sent from your app server, from, in that case, Nginx unit, to the proxy server, to the load balancer that sits on the very beginning of your processing chain. And this is something that is, or was, from my perspective, from my feelings, very, 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 very complicated for different languages. So Python handles it different than Ruby, than Java, and all that stuff. And with Nginx unit, it's a single way of configuring the TLS termination, certificate management, cipher configuration, TLS version configuration, no matter what programming language and what framework you're using. That's one of the coolest features we have on Nginx unit, and one of the most powerful security features I have configured on unit in production.
So you're saying I'm not going to have to use a Java key tool or esoteric OpenSSL commands and reconfigure my JRE lib security Java security file so it's using the right randomness source, all that kind of crazy platform specific configs, and then go do that again in Python, go do that again in Ruby. I can just go into one place, right?
Yeah. So yeah, from the examples you have just mentioned, I can definitely hear the pain, and that you saw the same kind of things than I did. And yeah, it's totally that the TLS encryption and all the things that comes with the encryption, certificate management and stuff, is something that is handled by Nginx unit, and I have a couple of more details on the next slides how that works technically. But long things very short, yes, it is totally correct. Nginx unit handles that for all the programming languages and framework you're using independently from those languages and frameworks, on a single place. So you just need to remember one single technology, and that's how to upload certificates and how to manage certificates with Nginx unit, and how to configure the listeners on unit to use a certificate or a specific TLS version, and ciphers. So no more pain with Java key store and things like that. So that's going to the past if you use Nginx unit to run your app code. A lot of questions come along over the last month when it comes to Nginx unit, asking, can I host Nginx unit in a container? Is it lightweight enough to do it? Can I host Nginx unit on a VM? Is it powerful enough to host all my application workloads? I have 20 PHP apps. Can I handle it? And the answer is it is definitely lightweight enough to put it in a container, and it is powerful enough to handle all the application workloads you have on a Linux VM, as Nginx is today. I mean, Nginx is still the most common used Docker image out there. And as you can see, you can run Nginx unit in a container without any problem because it is lightweight enough and fast enough to fit into a container. And on the other side, you can run Nginx on a VM handling millions of concurrent connections. And this is exactly what unit can do as well. It comes from the same forge. It's the same idea. It's the same production grade code base or idea of writing production grade code than Nginx. So it follows this path of lightweightness and powerful. Yeah.
So I'm kind of hearing an image here that, maybe for me, I don't need all the complexity that is, say, Kubernetes, right, for my apps. Really, I can deploy them all within a single VM, but I now have a management layer where I can redeploy or deploy new apps within that given unit and scale that all as a single unit. I don't need to worry about scheduling across this whole fleet and trying to debug affinity problems or noisy neighbor issues, because all of my app deployments are all they're all the same, but they're all containing unit.
Right.
For me, this seems like a great alternative for a very simple application architecture.
Yeah, right. Yeah, especially when it comes to Kubernetes, I have a strong opinion on that. There are definitely architectures and use cases out there where something like Kubernetes or OpenShift or Thymulus things are making a lot of sense. But on the same side, there are at least as much use cases out there where Kubernetes, OpenShift, and such orchestration platforms are too complex, too heavyweight for just run the application code. And that's something where unit can definitely bring benefits. And I have tested it on my end since 2 years now, trying to shift a lot of my production workloads from containers and things like PHP FBM configurations, heavyweight configurations to Nginx unit, and have a lot of good experience with that, especially when it comes, as you said, when it comes to deployments for specific languages like PHP and Ruby. It is definitely a good alternative to have a farm of Docker containers hosted on a VM with an Nginx proxy in front of it. Unit can definitely help here. It's a lot dependent on the use case, as with everything in our business. But if the use case is the right one and the complexity is handleable by something like Nginx unit, and the feature set we provide with Nginx unit is rich enough for the use case, it's definitely an alternative to something like Kubernetes and OpenShift, for sure.
And I'm kind of hearing too, it's not necessarily even either or though, right? Because you mentioned you can run it in a container.
Yep.
And so I can imagine maybe I have an environment where we had microservice sprawl, right? Where someone made a microservice for like MD5 checksums or something. And they're so micro, and we need to bring them in, right? They're just too many services. So what I'm hearing is you could use Unit to consolidate services into smaller chunks in a container and then deploy those containers within something like Kubernetes or Docker, and just have less communication over the network boundary. And you can kind of right size your microservices. This gives you a nice little dial to turn.
Right. So yeah, definitely. So this is another great example of why Nginx unit is, even in Docker, a powerful tooling. So let me take this as an intro to talk a little bit about unit in Docker and my experience. So just imagine, I mean, it's very, very, very simple use case, and I think a lot of engineers came across that is, let's have a PHP application running in Docker. So most of the time, I've seen container images having something like Nginx in it, and at the same time, you have something like a fast process manager like FPM, PHP FPM in the same container. That's good. That's great. That's configurable. But that means you have at least two processes running in this container. One process is the Nginx, the other one is PHP FPM. Good. Then, to make it a little bit more complex, as you already mentioned, you have something like Node.js because you want to do some PDF creation, and PHP is not the right tooling to that. So you use Node.js. You have another process. And multiple processes in a single container and start multiple processes in a single container is always pretty complex to handle. So Docker
Yeah,
is
you've got to bring in your own init system, and you can't
right.
just use systemd. You have to use runit or one of these other process
Yep.
managers. And you're wishing you were just in the VM world again.
Yeah. Right. So this is like the thing. So you have to take care of your own processes by yourself without, I mean, that's doable with scripts and shell scripts, and there are tutorials and stuff out there that helps you with that. But it's still, so at least for me, it always feels a little bit hacky to do this. And with Nginx Unit, for example, based on the process architecture of Nginx Unit, Unit takes care of its application processes, and this is something we have here on screen on a high level. Nginx Unit has a couple of processes, but it's like with Nginx itself. You have a main process, and the main process takes care of the controller process, the router process, and the app server processes. So, given that means that you can run Nginx Unit in Docker. That's great. And then you can host a PHP app, no, two PHP apps, three PHP apps, a Python app with Flask, Node.js, all that stuff in a single container. And the only thing you have to do is at the end of your Docker file, you call the unitd binary. It will spin up Nginx Unit. It will load the configuration from a JSON file if you want, and you're good. So no more complex process management for PHP FPM and Python, and maybe a Ruby app server beside the PHP FPM and all that painful stuff. It's all in a single unit. It's all in a single tool. That's Nginx Unit, and the main process is taking care of its trials and of its router and app server processes. So that's pretty handy when it comes to multi-process apps in a Docker container. And this container is deployable anywhere. You can run it on Docker on your local machine. You can use Docker Swarm. You can use Kubernetes. You can use OpenShift. You can use Fargate on AWS. Whatever. It's a container. So that's very powerful.
Yeah, and as you said, there's a common like entry point for all your processes. So
Yep.
you're getting central governance, but you're also getting a highly optimized network stack that allows you to process like 10,000 keep alive connections with just megabytes of memory, right? I mean, so these kind of best practices for network socket management, just like TLS, are wildly divergent across these application platforms. I mean, like in Tomcat, you may have to compile native code AGP to get anything close to a performant network stack. And so what I'm hearing, though, is you can get all this standardized across the apps.
Yeah. Right. Yeah, that's correct. So from what you can see here in this diagram, let me walk through it in the most interesting way it's possible. Walk through an architectural diagram. So let's start on the very top left with the controller process. The controller process is the process that takes care of the incoming API requests. So all the requests we send to Nginx unit will be handled by the controller process. The main process is handling the reconfiguration, but do not want to go into much detail this here because it's a technical thing that the main process is taking care of the configuration. The more important thing, or the most important thing when it comes to the feature you just mentioned, is this big green borrowed box in the middle that's called router process. And on a very high level, you can say this is the decoupling section from layer 4, network layer 4 to 7. So anything that's related to your network traffic, to like, let's say the ports you're opening, port 80, port 443, port 8080, stuff like that, this is bound to this process. So this process takes care of it. All the encryption part, TLS encryption, ciphers, certificate managed, and all the things that are important to do this happen in this process. So as you can see, this layer is decoupled in unit from all your application processes. So that means that gives you as a user the flexibility to configure listeners, let's say port 8080, port 8090, port 443, port 80, do an encryption with TLS version 1.1, 1.3, 1.2, whatever. And then you can bind this listener that's fully encrypted to an application, and then you're good to go. And then you can use another listener bounded to another application and another listener to another application. Or we have an Nginx unit, something that's called routes, where you can do very, very complex traffic management based on something like the HTTP host, URI segments, methods like post, put, stuff like that, get. And this is all independent from your application processes. So this gives you a lot of flexibility when it comes to handling your application workloads on Nginx unit. And this gives you the freedom to configure encryption, things like that, and do not spin your head around, okay, how I can do this with Go, how I can do this with Java, how I can do it with PHP. It's independent from the app server processes. Say that again, but this is the very cool thing, it's on unit, and as unit is configurable with a RESTful JSON API, for you as a user, it's a single API, it's a single configuration pattern you have to follow to configure your listeners and your applications in the same way. And if you want, Elijah, we can jump on a VM, and I can show you a couple of configuration examples and how that looks like in the wild. So cool, Elijah. We are on our server, and so let's see what unit can do in the wild. So I've just installed unit on that system, so unit is already installed and running. So let's do a little check here about the unit process, and it's exactly what I've just mentioned. It's the main process, the controller process, the router process, and at the moment we are having one unit demo application running on that one. It's a little PHP application. But that's exactly the way how unit works in that case. And another interesting thing, so let's do this one here. Let's grab a listen. So we have port 80 and port 443 at the moment opened by unit. And you can see the process that's handling this network stack, the network layer, is the router process. So this is like the technical view of that, what we just saw in this little diagram with this green bordered box. This is the technical implementation, or the in the wild view of what we just saw in the PowerPoint. So yeah, that's good. So that means we have a network connection. We can send a curl request to that. But more important is how to configure unit, and how to interact with unit. An absolute good resource when it comes to learn how to work with unit is the website, unit.nginx.org, and there is a whole section about how to send curl commands and how to interact with nginx unit and send configuration to it. Another good example I can give you here is a unit CLI. This is kind of a private project I have built to make it easier for me to interact with unit. It's a shell script, nothing more, nothing super fancy, that's wrapping the curl commands a little bit so that we do not have to send curl commands. So for example, I can do unit CLI -c to print the current unit configuration. And this is how it looks like. We have the certificate section, and you see we have a couple of Let's Encrypt certificates in here, or one certificate in here. We have the listeners section where we have a listener port 80 and 443. We have the routes. And this is exactly the route options I have pointed out in the PowerPoint. You can match a host, for example, and invoke some action. This is even here a very, very, very simple route configuration. As said, you can do a lot more complex things with routes, but this will definitely go beyond this intro video, showing in detail what routes can do. And
Timo, am I seeing Let's Encrypt in there?
yes, it's a Let's Encrypt certificate in here, and so what you see here is the backend or the unit installation I have created for a demo back for release 1.23, where we introduced the SNI support in Nginx unit. And what I have done here is I have created a small unit configuration that can handle the ACME challenges with Let's Encrypt completely within unit, without this standalone web server thing and stuff. It's all handled by Nginx unit. So Nginx unit will take care of the ACME challenge, and that's what we already mentioned a lot of slides before, that unit is a lot more than an application server, because it is a web server and it can serve static files as well. And this is what we need here to make this ACME challenge successful. Right, so yeah, that's definitely possible to work with Let's Encrypt and Nginx unit. And so yeah, this is a pretty easy Nginx unit configuration and one single unit application, a PHP application, and we have a single worker process at the moment. Here, this is the PHP application. And we can send a curl request, and I have to do this, or you can do localhost as well. Okay, so this is right now because the missing host header. We're not like thing on the protocol, and this is like the output of our PHP demo application, listening on port 443, and we can basically do the same on port 80. And yeah, so let's use this little demo app to show how to reconfigure unit and how that works. So first of all, let me show you a common way of reconfiguring Nginx unit. As said, this uCLI-C prints the unit configuration, and as it is a JSON format, you can use a curl command, for example. So my CLI prints the prints the location of the control socket. So Nginx unit, the control part of Nginx unit, can listen on a socket or an IP or TCP IP port. And the default configuration is a socket. Just it's a more common and more secure to have this socket, because if you expose this port to the wild, anybody can configure or reconfigure your Nginx unit instance. So that's why the default configuration is a socket. And so let's see what happens when we call the unit CLI C command here. I lost that one.
Timo, you'll want to remove the set. Just bash.
Yeah, there you
bash
go.
it.
So we do the C. Yeah, and as said, it is nothing too fancy. We use the Unix socket for curl and the location of the Unix socket, and then it's basically HTTP localhost. So let's copy this one and do that here, and you will see it's the exact same output. So we can pipe this to JQ, and it's pretty, right? So, and as it is JSON, you can drive down in this configuration path by specifying something like highest level is config, and then we want to see the listeners. Cool. So let's type localhost /config/ listeners. And that means you can just get all the listener information. Or if you want to have a specific listener, let's type *:80. See? And that's how it works. As it is JSON, you can navigate to a specific part of the configuration just by adding it to the path, to the URI. So that's the common way of reconfiguring or navigating inside of the unit configuration. And something I want to show you here is, this is a configuration example of this little demo application. As said, I'm using the unit CLI little shell tool I have built, and I use a file format called unit spec file, and that's just includes a lot unit configuration in a single file. And we're defining listeners, routes, and applications. The language is exactly the same as in a normal unit configuration. So we have listeners, we have routes, we have this pass command that tells unit where to send the traffic when it hits the port 80. And it's just another format that will be taken by my unit CLI and then sent to Nginx unit. And this is something we can do. So let's say we have this environment specified here as an environment variable in our app that called Nginx Sprint 2021. Let's change that and say 1. Why not? Save that. So what we can do now is we can apply that. You say unit CLI apply uspec.json, and there is a debug output. We can do this, and let's go through that step by step what it does. So unit configuration withered will apply the application config. Great. So we will see it change the environment variable. Reconfiguration done. So that's the unit message that all the reconfiguration was done successfully. Then we apply the network configuration. So this is the layer 4 part of the fence, this little green borrowed box we saw in the presentation. We apply the routes, and after the routes, we apply the listeners, port 443. We apply the listener for port 80. We are linking everything together, and we are good. And again, it's the same idea. We can say unit CLI use spec.json. and we will see our old friend curl that's sending a put request with some JSON payload to our config endpoint of Nginx unit. So as you see, I'm not hiding anything in my unit CLI. It's basically just the wrapper for the curl commands. But you can find all those curl commands on the documentation online. So it's not super fancy. It's something, get used to it, but it's all well documented. And the unit CLI will also be available on my GitHub repository. So all good. So that means when we do the curl again to port 443, it should now print the Nginx Sprint 2021-1. Cool. So this is exactly how it is. I mean, we can now reconfigure it again with some 2021 space or -2, -3, whatever, send it, and it will just work without any downtime here. Or another thing that is pretty handy is that there is a run user and group, and there is something like processes, and then you can define the number of processes inside your PHP application. They will just spin up 5 processes, 6 processes. So let's do 5, for example. I hope it is processes. I guess it is. Process must be an integer, not a string. That's fair. Right, that sounds good. So remember, we had this PS output with a single PHP application process, and this is this. So if you remember yourself back into a time where you configured PHP FPM with www.conf, for example, this is the same idea of having this idle start process count in PHP FPM, but with the difference that this can be controlled with a single API call. I mean, at this time we're doing this in a JSON file, but as said, we can navigate to exact this value by typing applications, unit demo, processes, to get the current number of processes configured. And if you want to change that, it's the same easy way. Use localhost config, applications, unit demo, processes, 8, 10, 15, whatever, send a put request, enter, reconfiguration done without any downtime. And that's the real benefit of Nginx Unit, that it combines this layer 4, layer 7 configuration parts in a single API. And that all happens without any downtime.
You know, there's a small thing here I really like, and that's in that application process, it actually gives you the name of the application there in the PS output.
Yeah, exactly. So just imagine how would it look like if you have 25 PHP applications, or even 10. I mean, have 10 applications running on a single unit instance. How you would like try to find out what application is what. I mean, you can have a different run user per application. That's possible, but this is pretty handy output to say, look, this is unit demo, this is unit demo 1, this is app 2, this is app 3. Yeah, it makes it very easy to maintain and to work with. All right, so yeah, as I said, the unit CLI is not hiding anything. It's just making my life as a system administrator a lot more easier. So yeah, what we have learned here is that we can easily add anything to a configuration, either by typing it in a JSON file and apply that with a unit CLI or a curl request, or by sending it ad hoc to the config endpoint. we saw the certificates and the encryption part. So that's how it works. And this is the coupling of layer 4 and 7. Right, and for this listener, we have configured one certificate, and as mentioned, we have this SNI support since release 1.23. So that means we can have 5, 6, 7, 8 certificates here configured on this global port 443 listener, and Nginx unit will then get the right certificate for the configured host name automatically based on SNI. So with that feature, we do not even need something like an Nginx in front of it, as unit can handle the certificate and the encryption completely by itself. And even better, you do not even have to specify where or what host name you want to use what certificate. It's one big certificate store with all the certificates in it, and a configuration, a list of certificates here on the listener, and all the rest will be handled by Nginx unit automatically. And that's definitely a pretty awesome feature since the latest release, or since release 1.23. Yeah, that works pretty good. So yeah, that's basically I guess a good point for an intro. So we've seen how to configure it. We have seen how the process structure of unit is in general, and how easy it is to reconfigure unit using MyCLI or their CLI, or using something like curl or a CI pipeline, whatever you want to do. Quite anything that can send an HTTP request to this server will be able to reconfigure unit for you. Yeah, that's all from my end. So I really appreciate your time and the time you have spent with me, and want to give the last word to my colleague and friend Elijah.
Thank you, Timo, for that presentation. Yeah, this is great. And one of the things I do want to prompt the community is, if you're using Unit in any sort of open source projects, give us a ping, send us a message. We'd love to hear what you're doing and offer, some support or guidance. Thank you all.